6.3, we got f of x equal e to the x. See, that looks like e to the 0 is 1. E to the 1 is e, 2.7. And 1 over e is 1 over 2.7, which is about a third. So it looks something like that. And we're going to rotate this about the x-axis on the interval from 0 to 1. So we've got this shape that's going to go round, so it's going to be down here. Be down here looking something like that. Okay, so we slice it. Since this is the disk method section, we slice it perpendicular to the x-axis, because that's what we're rotating it around. And so the thickness here would be dx. The area would be a circle. So we have dx integral. X is going to go from 0 to 1, 0 to 1. And it's going to be pi r squared, pi. The radius is this way, which is y. Pi y squared. But y is e to the x squared. So we got pi integral from 0 to 1 of e to the x squared. You multiply the exponent, or e to the x times e to the x. When you multiply, you add the exponents, so e to the 2x dx. Integrating this, I could let u equal 2x and do it by substitution. But if I took the derivative of this, I would get e to the 2x times 2. But I don't have it, so I have to have it divided by 2 times pi, evaluated from 0 to 1. I put 1 in there, and I get pi e squared over 2 minus, put 0 in there, e to the 0 is 1, times pi over 2 is just pi over 2. I could factor the pi over 2 out of this, and I get pi over 2 times e squared minus 1. Either of these answers would be just fine. Okay, we got a region R where an f of x is bigger than g of x, it says. So I'm going to make f of x and g of x, and the region between them is what we're looking at. And we're spinning it around y of minus 1 minus 2. So a slice would be, this is the axis, we do the disk, so it would be a slice like this. Its thickness, it would show up down here. Its thickness is in the x direction, so that's dx. So we'd be doing an integral with respect to x. And we'd be integrating pi r squared. So the r would be a big R, which is up to there. And the little r, it'd be there, going around. And so we have to do the big R, which would be this height, which is f of x. plus 2 more. So that would be the big radius, pi big radius squared, minus the smaller radius. That would be this one, which is g of x, plus the 2 more. G of x is this, plus 2 more, because that's the x-axis. G of x plus 2. That's the smaller radius, squared dx. So the integrand would look like that. Which one of these is that? And that looks like 2. They don't have the pi, they don't have the integral, they don't have the dx, but they want to know what's the stuff inside that you have to integrate. All right, 27. We're going to flip this around the x-axis. So here's the axis. So if we got to do a slice perpendicular to it, so a slice would be like this. And so there'd be a large radius. And a small radius. The thickness is dx. The large radius, we're going to do this from, since it's an x, from 0 to 2. The large radius is 6 pi 6 squared minus pi times the small radius, which is x squared plus 2 squared. And that's the setup. All we have to do is integrate this. So we've got pi 6 squared is 36. Integrated is 36x from 0 to 2. And then this is no good use substitution here, so we'll just multiply this out. That would be x to the 4th plus 4x squared plus 4. And we're subtracting all of this, and that integrated would be x to the 5 over 5 plus 4 over 3x to the 3rd plus 4x. That evaluated from 0 to 2. And so 2 in here is 72 pi minus 0. This would be 32/5 plus 125 times 4 is 500 thirds plus 8. Putting in 0, we get nothing, and so we got to take this away from 72 pi. Oh, and the pi is times this one also. Pi times this, and pi times that. I probably should put it right in here. There we go. So 32/5 is 6 2/5. 500 thirds, that's 1, that leaves 228. 6 is 6.6666, or 6 2/3 plus 8. And all of this is times pi and subtracted from that. Oh, that doesn't seem right, because we're going to get a negative answer here. And we shouldn't get a negative answer. So what did I do wrong? X squared plus 4. So all these are subtracted. This is the red radius. That squared, we got to subtract that from the other. x to the fourth, 4x squared plus 4 integrated is x to the fifth over 5, 4x to the third over 3 plus 4x, 0 to 2. Oh, here's what I went wrong. 2 to the third is 8. I was thinking 5 to the third. 2 to the third is 8 times 4 is 32. 32 thirds. And 4 times 2 is 8. I messed that one up. Sorry. That's why it doesn't look right. 3 goes in there, 10 and 2 thirds. So 2 thirds, so 10 plus 6 is 16, plus 8 is 24, plus 2 fifths, plus 2 thirds. And that's times pi, and we're taking that away from 72. 72 minus all of this. So, and that's all times pi. So 72 minus 24, that's 68, 58, 48. 48 minus 2 fifths is 47 and 3 fifths, and minus 2 thirds times pi. 2 thirds is 10 fifteenths. 3 fifths is 9 fifteenths. So it'd be 46. This is minus a 15th. So 47 minus a 15th is 46 and 14 fifteenths pi. Hopefully I don't make too much of a mistake there. Made a mistake here, got it fixed. All right. Now we got to do y equals x squared. That's the simple parabola, 1, 1. 12 minus x, so I got to go up to 12 and do minus x. So this crosses up here at 12. It's decreasing. And x equals 0. X equals 0 is this line. So we got this region here about y equals minus 2. Y is minus 1 minus 2. So the slice would be, we're going about this, the disk would be something like this. Its thickness would be in the x direction, dx. So we'd have dx is my thing. We're going to go from 0 to wherever they meet. Let's see. If we go 4, that would be 16. 12 minus 16. 12 minus 4 is 8. That's not where they meet. 3 squared is 9. 12 minus 3 is 9. Oh, they meet at 3, 9. So I'm going to integrate from 0 to 3. And it's going to be the large radius, which is from here clear up to there. Well, this height is that y, but that's only from there to there. We have to add 2 more. So it's 12 minus x plus 2. And we got to do pi radius squared minus the smaller radius, which is from there to there. This part right there is the x squared. So it's x squared plus 2 squared. And we got to take the large radius minus the small radius. So now it's just algebra and integration. Pi 0 to 3, 12 minus 2 is, plus 2 is 14 minus x. squared is going to be, actually I can integrate that without doing it, because the derivative of that's only going to produce a minus. So, well, I'll just write that 14 minus x squared. I can integrate that without doing much. I could do a u substitution for that and it'll work. But this part is going to be minus the integral pi integral 0 to 3 of, that squared is x to the 4th plus 4x squared plus 4. Okay, the integral of this is going to be, the derivative of this would be minus 1. So it's going to be 14 minus x. The power rule would change this to a 3 and divide by 3. But the derivative would produce a negative. And that's times pi. Evaluated from 0 to 3. And then we have minus pi, and then we have x to the 5th over 5 plus 2x to the 3rd plus 4x, evaluated from 0 to 3. So both of them are times pi, and we have 14 minus 3 is 11 to the 3rd over 3. (11 to the 3rd divided by 3). 4, 4, 3 and 2/3 minus, and 0 in there would be 14 to the 3rd divided by 3. 9, 1, 4 and 2/3. And this is minus, so that would be minus this and plus this. So we're going to take this one from there. The 2/3 are going to cancel in there. So that would be 9, 1, 4 minus 4, 4, 3. So that's 471 pi minus, and then we get some pi times, what do we get here? That is 81/5, 2754 plus 12. 0 in there is 0, so just that. 81/5 is 5 is an 8, 1 leaves 3, 6 and 1/5. So we got 16 onto 54 is 70, 82 and a 5th pi. So we got 471 minus 82 minus a 5th is 388 and 4/5 pi. 4/5, which is 0.8. That's what I get. The main idea is getting it set up. If I make an arithmetic here, I'm not going to be. That's not the important thing. Is understanding how the setup goes, and I think he got that. Let's continue. So that's it for that section.